Okay, so Junior Roberts here. We're doing another physics worked example. So this question is about combinational logic circuits. So we're just going to go right into this video. Okay, so our question goes like this. It says that the figure below, figure 2, shows a combinational logic circuit, and we can see our combinational logic circuit with a few logic gates here. Now the first thing this question wants us to do is to examine the circuit and identify the logic gates shown. Right, so to do that, what I'll be doing is to actually set some labels for these gates. Right, so I can say this is labeled A, this is B, and this is logic gate C. Right, so now to actually list the name, I'm gonna go here and then I'm gonna say A. Logic gate A is my NOT gate. Logic gate B is my AND gate, and logic gate C is another AND gate. Right, so these are our three gates that are listed in the circuit here. This is a NOT gate, this is an AND gate, and this is also an AND gate. And as we mentioned the name of these gates, if you need a quick refresher about the different types of logic gates, I've done a complete series outlining all the 5 basic logic gates. I will list it in the description below, and also put a notification at the top of the screen so you can go ahead and check out that series to learn more about logic gates. Right, so we have identified all 3 logic gates. Again, this is a NOT gate, AND gate, and another AND gate. Now let's see what else the question wants us to do. So the question wants us to also draw and complete the truth table for the combinational logic circuit shown. Alright, so let's look back at our circuit. So this is our circuit. We have 2 inputs, input A and input B, and we have 2 output X and Y. And we have some subsidiary, well, we have a single secondary input, right? And we can label that W. So we're gonna have these as our headings. These will be our input A, B, our output X and Y, and then we have a secondary input. Alright, so I'm gonna go ahead and draw up the table. Okay, so this is my table drawn up, so I'm gonna actually go ahead and start to fill out the table. But let me just take a second look at the circuit. So again, we have our input A and B, so I'm gonna fill those out first. So we have input A and input B, right? Then those are our primary inputs. Then we have a secondary input, we call that W. So we have a secondary input W, and then we have our output X and Y. So X and Y. Now whenever we're looking at combinational logic circuits, we have to look at each gate independently and look at the input and also the output. Right, so before I go ahead and actually start to fill out the truth table, I need to fill out the possible combinations for my input. So for the input, starting with column B, we're gonna have 0, 1, 0, and 1. Then for column A, we're gonna have 0, 0, 1, 1. So those are my possible combination for my input. Now I need to start to fill out column W, so I need to actually look at the gate that controls the output, which is at W here. So going back to the logic circuit, I see that the output W comes from a NOT gate, and this NOT gate is actually connected to my input A. Right, so I need to focus on input A, consider it going through a NOT gate, and then determine what will be the output at W. So we're gonna go ahead and do that right now. So we have A going into a NOT gate and produce W. So whenever we have a 0 at the input of a NOT gate, we will get a 1 at the output. Whenever we have a 0, again, we'll get a 1. Now, when we have a 1 going at a NOT gate, we get a 0 as the output. So we have 1 going in, then we get 0 as our output. Now we're going to start to fill out column X. So again, we need to actually focus on the gate that controls column X. So X is the output of an AND gate, and X is the output of an AND gate, and this AND gate is connected to our input A and input B. So we're going to look at those two inputs and consider the function of a AND gate. So we have A and B going into an AND gate. Now the only way we will get a 1 at the output for an AND gate is if we have both 1s at the input for the AND gate. So when we have 0 and 0 to an AND gate, we get 0. 0 and 1 to an AND gate, we'll get a 0. 1 and 0 to an AND gate, we'll also get 0. And then 1 and 1 to an AND gate, we will get 1. Right? Now, when you look at column Y, we have to focus on the gate that controls column Y. So column Y is connected to the output of an AND gate, and this AND gate is connected to input W and input B. So we're going to focus on those when we're filling out column Y. So we have W and B going into the AND gate and produce Y. And again, we know that we only get a 1 at the AND gate whenever we have both 1 at the input, which occurs right here. So we have when B is 1 and W is 1, we're going to get a 1. Otherwise, 0 and 1, we'll get a 0. 0 and 0, we'll get a 0. And 1 and 0, 1 and 0, we'll get a 0. Right? So that would be our truth table for this combinational logic circuits. Again, if you need to revisit logic gates, I'll put a link in the description for a complete series that I did on logic gates. Again, this was Junior Roberts coming to you with realjuniorroberts.com. If this video was helpful, please hit the like button, consider subscribing, and hit the share button so others will be able to benefit from this. If you have any questions, post them below in comments and I'll do my best to clear up any misconceptions for you. Thank you for watching.